I'm going to be explaining question 7 and question 10 of the homework. And so starting with question 7, where we're given equations and asked to find the values of theta between 0 and 360 degrees. So for 7a, we're given cosec squared 2 theta equals 4. So the first step that I did was convert cosec squared into 1 over sine squared. So you get that. And because we know that 1 over sine squared 2 theta equals 4, we can get sine squared 2 theta equals 1 over 4. Now, if you square root both sides, what you get is sine 2 theta equals plus minus 1 over 2. And then you can, on the calculator, do sine minus 1 of 1 over 2 and negative 1 over 2 to get 30 degrees and negative 30 respectively. And so for this, when we're looking at the unit circle, we have to find values between 0 and 720 because we know that theta is between 0 and 360. So now what we can do is look on the unit circle. You see here we have the 30 degrees and the negative 30 degrees. Obviously it can't be negative 30 because it's between 0 and 720. But you also get the same value when you have 180 minus 30 degrees, which is 150. You also have the same value when you do 30 plus 360, so going around full circle, and 150 plus 360 around full circle again. You also have this kind of negative 30 value, but you can get that by doing 180 plus 30 or 360 minus 30, which gives you the same kind of sign value here. And so you have all these results, and then once you get all of these, you divide them by 2 because these are results for 2 theta, whereas you want it for just theta. So after dividing by 2, you get 15, 75, 105, etc. For question 7b, it's the same principle. You're given the equation cotangent squared 1 over 2 theta equals 0.9. So the first step is to just express cotangent squared theta as 1 over tan squared 1 over 2 theta, and also express 0.9 as 9 over 10, just to make it easier to do the second step, which is to do the same, find the reciprocal, so you get rid of the 1 over 2 and just, 1 over tan, and just make it tan squared 1 over 2 theta. And then what you can do is square root both sides, so you get tan 1 over 2 theta equals plus minus root 10 over 9. And from that you can, on the calculator, do tan minus 1 of plus minus root 10 over 9, and you get plus minus 46.5 degrees. And for this, because we're working with 1 over 2 theta instead of theta, it goes from 0 to 180 instead of 0 to 360. So again, going back to the unit circle, you have this original 46.5 degrees that you're looking for, and the negative that you're looking for. And because here you're working with a positive sign and a positive cos, you get the same thing with a negative sign and a negative cos. So 46.5 plus 180 would give you the same value for tangent, but then this doesn't work because we're working with 0 to 180, whereas this is over 180. But you can do that for the negative 46.5, so that plus 180 is 133.5 degrees. So the values that you get for theta, half theta, are 46.5 degrees and 133.5 degrees. And to get those values for theta, you simply double them and you get 93 and 267 degrees. For question 7c, you're given sec squared theta plus 1 equals 3 tan theta, and what you can do here is use the trigonometric identity of sec squared theta equals tan squared theta plus 1. So here I converted this to tan squared theta plus 1, and then the rest of the equation there. And what you can do is rearrange this to be basically a quadratic. So you get tan squared theta minus 3 tan theta plus 2 equals 0. And what you can do is factorize this, so you get the values for tan theta of 1 or 2. And what you can do for that is, on the calculator, do tan minus 1 of 1 and 2, and you get these values for theta. and then you go and find the other possible values for them, again with it being 45 plus 180, giving you a negative sine and cos instead of a positive sine and cos, which gives you the same thing. The same for 63.4 degrees plus 180 degrees. So in the end, you get the values for theta of 45, 63.4, 225, and 243.4 degrees. For question 7D, you're given cosec squared theta equals 3 plus cotangent theta, and I want to get rid of the cosec squared theta. So what I do is, using the trigonometric identity of cosec squared theta equals 1 plus cotangent squared theta, I convert that into cotangent. And then what you can do is, same as before, rearrange this into a quadratic equation and factorize it. So you get the values of cotangent theta being negative 1 and 2. So you get tan values because you know that cotangent theta is 1 over tangent. If cotangent theta is negative 1, then tangent theta is 1 over negative 1, which is the same thing. And if it's 2, then it's 1 over 2. And you go on the calculator, you type in tan minus 1 of negative 1 and 1 over 2, and you get these. And then you find the other values. You do the same thing of adding 180 degrees so that a positive sine and cos here becomes a negative sine and cos, which gives you the same value. So in the end, you get theta values of 26.6 degrees, 135 degrees, and 206.6 degrees. For 7E, you're given a similar equation, and again the idea is to try to get rid of or make it all secant or tangent so that you don't have the other one to deal with, and make it into a quadratic equation where you can solve it. So I use the identity tan squared theta equals sec squared theta minus 1, and so I converted the tan into sec, and now I rearrange this to become a quadratic equation. This one is a bit more difficult to factorize, so what I do is I use the quadratic formula and substitute all the values in. You can see that this is basically the x of the quadratic quadratic equation, and this is the a, the b, and the c, and you just substitute them all into the quadratic formula, and you get 2 and 1 over 3 for sec theta. And so on the calculator, you can't just work with sec theta to find the values, so you convert these into cos theta, because you know that sec theta is 1 over cos theta. If sec theta is 2, then cos theta will be 1 over 2. Same if it's 1 over 3, then cos theta is 3. And you substitute these values into the calculator, and you get cos minus 1 of 1 over 2 equals 60 degrees. You cannot substitute 3 in because the maximum value of cos x is 1, as you can know by looking at a cos graph. And then same as before, you just get all the other values. If you look here, it's 60 degrees, and to get the same cos value, you basically just minus the 360 degrees from 360 to give you 300 degrees. For question 7F, it's the same thing, except you're working with cotangent squared theta and cosec theta. So you get rid of the cotangent squared theta by using the identity cotangent squared theta equals cosec squared theta minus 1. So I substitute that in here. And then you just expand this and rearrange the whole thing to get yourself that quadratic equation. And then you use the quadratic formula again. You substitute all the values for a, b, and c. And so you work that out, and you get values for cosec theta of 3 over 2 and 2. And so once again, you can't work with cosec. So you know that cosec theta equals 1 over sine theta. So if it's 3 over 2, then sine theta is 2 over 3. If cosec theta is 2, then sine theta is 1 over 2. and then you substitute those into the calculator to get 41.8 and 30 degrees for theta, and you just try to find the other values. You see you have the sine values here of 1 over 2 and of 2 over 3, and then you just get the same values on the other side by doing 180 degrees minus the 41.8 and the 30 to get you 30, 41.8, 138.2, and 150 degrees. Moving on to question 10, where the question asks you to sketch graphs of y equals sec x, y equals 2 sec x minus pi over 4, and finding the transformation which map this onto this. So you start off with y equals cos x graph. I've started off with the graph of that because we know that y equals sec x is the same as y equals 1 over cos x. So starting off with that, let's just take a look at some values on this graph. So you have a value of 1 here, a y value of 1, and so when you take that onto the y equals 1 over cos x, if cos x is 1, then 1 over cos x will be 1 over 1, so then that will be the same thing for a graph of y equals sec x. So if you just plot that there, and then if you take the value of 0 here, of y equals 0, then you get 1 over 0, which we know is infinity, so then you get a vertical asymptote here. And so at this point, the graph of y equals sec x will be infinity. And the same for this side, as this side reaches 0 as well, so then this creates a vertical asymptote, and you have a graph here of y equals sec x. And then for these values down here, we have a value of y equals 1 for the graph of cos x. So for the graph of sec x, it'll still be y equals 1 because 1 over 1 is 1. So you have that here. And the same thing, we have a vertical asymptote where this reaches 0 here and here. But instead of going up to positive infinity, because it goes up from negative infinity, we have a graph that looks like that. And we do the same thing for every time that this reaches 0 here and reaches 1 here. So then you have a graph that looks a bit like this. It's kind of horribly drawn, but you kind of get the idea. You have the vertical asymptotes here, and the parts where they touch are where the y values are 1. And then you're asked to sketch a graph of y equals 2 sec x minus pi over 4. So we know that that's the same as y equals 1 over cos x minus pi over 4. So then, oh, sorry, it should be 2. So because you have the 2 here, you know that you get a vertical stretch by a factor of 2. So instead of having a y value of 1 here, you get a y value of 2. Same for the other ones. You also have this x minus pi over 4, so we know that this is a translation by pi over 4. So instead of this being here at x equals 0, this will be instead here at pi over 4. So this will be around here, and you also have the vertical stretch. So then you get a graph that looks kind of like this. And the same for all of the other points. You still get those asymptotes, but the graph is just stretched and it's also translated.